Greetings to everyone and welcome to this tutorial. Today we are going to be looking at pure maths with mechanics of June 2023, paper 3, question 5. This question has to do with projectile motion. So here we are going to see the projection of a particle. I read the question. A particle is projected from a point A on a horizontal with speed 50 meters per second at an angle of elevation alpha, so that it passes through the point 120 Now A, show that there are two possible angles of projection. Show that there are two possible angles of projection. Alright, let's begin with the solution. To solve this problem, we need to first of all draw. Remember, it is always essential to draw so that you see what is happening before you begin to analyze the problem. So we have a system like this. We have a system like this. Vertically we have y, and horizontally we have x. Now the particle is projected from a point A, and the particle moves. This is the path of the projectile. It moves like this. The distance from here to here is going to be the range. Now it is projected with a speed or a velocity. It's projected with a speed of 50 meters per second. This point here is going to be the maximum height, h max, and it passes through a certain point. It passes through a certain point we are due. It passes through the point 120 10. So this is our now it is projected at an angle of alpha with the horizontal. So if it is projected at an angle of alpha to the horizontal, it means that this horizontal component of the velocity, the horizontal component of the velocity is going to be 50 cos alpha, and the vertical component will be 50 sine alpha. So this is the diagram. Now we begin with A, which says that show that there are two possible angles of projection. Now how are we going to show that there are two possible angles of projection? We are going to use the equation of trajectory or the equation of path. This equation is given as y. The equation of trajectory of the projectile is given as y equal to x tan of the angle alpha minus g x squared. G is gravitational acceleration divided by 2u squared cos squared alpha. This is the equation of path, equation of trajectory. So we are just simply going to substitute the values in this equation of trajectory and see what it gives us. Substituting in this equation of trajectory, we are going to have y. We are told that the particle after projection passed through a certain point with the x coordinate 120 and the y coordinate 10. So y here is 10 equal to x 120 tan of alpha minus gx squared, that is 10 x squared 120 squared over 2 u is 50, the u is the speed, 50 squared cos squared of the angle. Now we have that 10 is equal to 120 tan of the angle alpha minus 10 times 120 squared divided by 2 times 50 squared, then all this times 1 over cos squared alpha, like this. Now let's recognize that 1 over cos squared alpha is sec squared alpha. So we are going to have tan alpha minus this quantity is 10 120 squared 250 squared, then sec squared alpha. Now we are going to have that. We're going to have 10. We're going to have that 10 is equal to 120 tan of alpha minus this quantity. This quantity is 144 on 5 sec square alpha. But now sec square alpha is 1 minus tan square alpha. So I'll replace it with 1 minus tan square alpha. Now let me multiply 2 by 5. I have 50 equal to 600 tan alpha minus 144 into 1 minus tan squared alpha. Now it means 50 is equal to 600 tan alpha minus 144 plus 144 tan squared alpha. Alright, I rearrange this equation now as a quadratic in terms of tan alpha. I am going to have 144 tan squared alpha plus 600 tan alpha. Then now minus 194 equal to 0. Now we can divide by 2. So we have that 72 tan squared alpha plus 300 tan alpha minus 97 is equal to 0. So if we let tan of alpha to be equal to t, so we have that 72 t squared plus 300 t minus 97 is equal to a quadratic, and so t is going to be negative 300 plus or minus square root of 300 all squared minus 472 negative 97. All that divided by 272. We evaluate. Stop the video. Started.
Yes, sir.
So from here we have that t can be equal to 3.81. And t is the same as tan theta, or t is equal to 0.353. So it means tan theta, tan alpha 3.81, and alpha is the tan inverse of 3.81, which is 75.29 degree. If tan alpha is 0.353, then alpha is the tan inverse of 0.353, which is 19.44 degrees. So clearly, we see that there are two possible angles of projection, and that ends the solution to A. Now we go to B. Now I am looking for the maximum height, and the maximum height is H max is given by u squared sine squared alpha on 2g. Now I'm looking for the maximum height given that the angle of projection was 30 degrees. So now I know my u, the speed was given as 50 sine of 30 squared on 2g. Now I have 50 squared as 2,500. I have sine 30 as a half, and times sine 30 squared is 1/4. So I will have 4 times 2 times 10. And this is the same as 2,500 divided by 8. Alright, so 250 divided by 8. So H max is equal to 3125 meters. This is the maximum height, provided the angle of projection is 30 degrees. Finding the range. He said find the range. Find the range of the particle on the horizontal plane through the point of projection. So now the range is this x, the horizontal distance moved, is given by u squared sine 2 alpha on g, which is going to be equal to this 50 squared sine 2 alpha. 2 times 30 is 60 on g. Now 50 squared is 2,500, and the sine of 60 is 3 on 2, 0.86 on 10. So I'm going to have sine of 60 times 250. This gives me 216.5 meters as the range. This is the horizontal distance moved. Meanwhile, in B, we're looking for the maximum height, which was the vertical distance. Now we go to D. Finding the time of flight. The time of flight, T, is 2u sine of the angle alpha on G. And this is the time from the point of projection, the time from the projection till the maximum range. So this is going to be equal to 2 times 50 sine of 30 on 10. Now 2 times 50 is 100, sine of 30 is a half, and we divide by 10. So this is divided by 20, and we are going to have it as 10 on 2 is 5 seconds. The time of flight is 5 seconds.